Today, we're doing a deep dive into something that feels like a total rewrite of how developers work. We're cracking open the 2025 Definitive Guide to Vibe Coding Tools. This guide. It's based on a huge AI survey, really a landmark piece, mapping out, what software development looks like next. For the past couple of years, honestly, it feels like we've been stuck talking about autocomplete. Helpful, sure, a little refactor here and there. But the sources we're looking at today, they're pretty clear. That era, it's over. So our mission here is to really define this new thing, vibe coding, and give you a practical playbook. How do you build an AI dev stack that gets the balance right? Speed versus project risk. This is about making smart architectural choices, not just turning on a new feature.
Yeah, and that term vibe coding, interesting, isn't it? It sounds a little subjective, maybe.
Mhm.
But the way the guide frames it, it's actually a formal discipline. It's outcome-first development. That's the key phrase.
Yeah.
You're judging the AI by what runs, what passes the tests, what actually meets the architectural goals you set. You're not just watching it type anymore.
Okay, I like that clarification. Outcome first. Because vibe coding on its own, yeah, it does feel a bit provocative. Like you're focused on the feel of the software, not the typing.
Exactly. And that totally flips the developer's role, right?
Right.
You stop being the main person writing code line by line. Instead, you become the context curator
Yeah.
and the quality arbiter. Your job shifts. It's more about strategic oversight, setting really clear constraints, making sure the environment has great documentation, API specs, all that stuff, and, crucially, setting up the feedback loops. That's how you teach the agent what good looks like. The machine does the work, but you're providing the map, the compass.
Okay, so let's unpack that structure. If this is a formal discipline, there must be some kind of taxonomy for these workflows. The guide mentions, three key factors: human QC, planning upfront, and how good your context management is.
Absolutely. Nailing this taxonomy down is, I think, the most important first step if you want to use these tools strategically. And yeah, based on those axes, the guide lays out 5 distinct models, and they're definitely not interchangeable. You need to pick the right one for the job. So let's start at one extreme, speed. That's the Unconstrained Automation Model, or UAM. This workflow, it's all about velocity. You basically accept working code with minimal human review. Very little upfront structure imposed. It's great for banging out demos, quick prototypes, that kind of thing. Proof of concepts, but, and this is a big but, the source really warns you. This model piles up technical debt and security risks like nobody's business. It's the fast food option, useful sometimes, but you can't live on it.
Right, okay, that makes sense. But if UAM is fast but risky, what's the sort of safer default
Right.
for just everyday development work?
Good question. That leads us straight to what seems to be the most popular and probably most sustainable model. The Iterative Conversational Collaboration Model, ICCM. Think of it like pair programming, but supercharged. The human is still the navigator, the reviewer, but the AI, it's the driver. And it never gets tired. It's hyper-efficient. You review each little change the AI makes. So you keep those human guardrails firmly in place. The big difference from old-school pairing is just the sheer speed and stamina the agent brings.
Okay, so it's not just putting a new label on pair programming, it's amplifying it. ICCM gives you speed but keeps the human oversight. But what about bigger projects, where the overall architecture is more critical than just banging out one feature?
Then you probably level up to the planning-driven model, or PDM. With PDM, the human developer or maybe an architect, they create a pretty rigorous design first. High-level diagrams, how components interact, that sort of thing. Then, the agent's job is strictly implementation. Just execute that pre-approved plan. PDM really shines when you need clean architecture, separation of concerns, keeping things consistent across a large project. And right alongside PDM, when quality is paramount, you've got the test-driven model, TDM. This is where the machines really verify the work. Instead of telling the agent how to build something, like in PDM, you tell it what it needs to do. How? By writing tests, objective standards. The agent's only goal is to write code that makes those tests pass. Green check marks. You define done, the tests enforce it.
TDM. Yeah, that sounds perfect for anything critical. Finance apps, safety systems, where being correct is way more important than being fast.
Exactly. And then there's the 5th model,
Yeah.
which is, well, it's a bit different. The Context-Enhanced Model, CEM. This isn't really a separate workflow lane. It's more like a booster. It helps any of the other 4 models work better. CEM is all about setting up strong RG systems, retrieval-augmented generation, indexing your docs really well, having powerful code-based search, linking to architectural decisions.
Well, why isn't that just standard? Why call it out as a separate model? Is it hard to set up?
It definitely takes some effort, some complexity to get it right. But the payoff It's huge. The main benefit the guide talks about is cutting down on what it calls flailing. When an agent just gets lost in a big code base or starts hallucinating API calls, that's flailing. CEM makes sure the agent has the right context. Consistently, it makes UAM less dangerous. It makes PDM implementation smoother. It just helps everything.
Okay, this is where it gets really practical. Let's say my team is mostly working in the ICCM lane, maybe dipping into TDM sometimes. How do the actual tools map onto this? The guide breaks things down into, what, 3 main categories of vibe coding tools. Let's start with the ones inside the editor, the IDEs.
Right, the embedded IDE tools. When you're looking at IDEs in this context, you want deep project awareness. Cursor really stands out here. It's built as an AI native editor from the ground up. It's good at understanding the whole project, not just the file you have open. That kind of project-wide view is gold for doing multi-file refactors or just figuring out a code base you're not familiar with. So, yeah, strong fit for ICCM and also for PDM when you need to explore before planning. And then there's Windsurf. This one's interesting. It's more of an agentic IDE. It's built around integrating the planning and the execution. It has this thing called the cascade flow system. Basically, the agent can plan multi-step tasks, run terminal commands right there in the editor, and then check if it worked. So if you hate switching between your editor, your terminal, your planning docs, Windsurf tries to pull that all into one loop.
Okay, interesting. Now, stepping outside the editor, the terminal power users, the CLI agents, these feel like they'd be perfect for that tight run, fix, repeat cycle you need for vibe coding.
Totally. They're often built around discipline. Aider is a great example. Very disciplined, very Git-centric. It acts like a pair programmer in your terminal. It keeps a good map of your repo, and it's almost obsessive about making small atomic diffs. It auto-commits carefully, makes the history clean, easy to roll back. That makes it fantastic for TDM workflows, right, where you're iterating fast, trying to get tests to pass. Then you have Claude Code, another terminal-first agent, but its focus is maybe more on state management. It uses something the sources call MCP tools, model control point tools.
Hold on, MCP tools, that sounds like new jargon. What exactly does that mean?
Yeah, good flag. Think of MCP tools as sort of advanced undo or state saving for the agent itself. Specifically, Claude Code offers checkpoint and rewind. So if the agent tries something complex, runs a build, attempts a big refactor, and it messes up, you can literally rewind the agent's state, its memory, back to a point where things were okay. It runs locally, you see the steps, and you can undo them. This makes those riskier multi-file changes feel a lot less scary. You're less worried about the agent going rogue because you can pull it back.
Ah, I see. That definitely helps with the agent drift fear. But what about big companies, regulated industries, where you need more than just rollback? You need audit trails, total control.
Yeah, for those high compliance places, control trumps speed. Cline is built specifically for this. It's a client-side agent designed around zero trust. What that means is it needs explicit, auditable human approval for everything. Every file it wants to touch, every command it wants to run. If you need a rock-solid paper trail for compliance, proving exactly what the AI did and who approved it, Cline is pretty much essential. And then within those more conservative stacks, you also see tools that give you high trust, maybe without being full-blown agents, like Tabnine and CodeWhisperer. Tabnine really focuses on enterprise privacy, offers on-prem options, which is huge for some orgs. CodeWhisperer ties into AWS, brings security scanning, license checks. Useful stuff. You often see these integrated with stricter CLI agents like Aider or Cline to get some velocity, but within very controlled boundaries.
We've covered the models, the tools, but let's talk about the why. Why do these guided agents actually work? The survey keeps coming back to the feedback loop. What are the absolute must-have signals you need wired in?
Right, the agent is fundamentally a learning system, isn't it? And it only learns effectively if the feedback is fast, clear, and objective. The guide really hammers on 3 essential feedback mechanisms. You need these pretty much regardless of the model you pick. First, the cheapest, fastest signal you can get. Compiler feedback, syntax errors, type mismatches. The compiler screams, the agent learns instantly. Oops, typo. Second, unit tests. These are your objective standard of correctness. They don't care how the code is written, just does it do the right thing? Pass, fail. Simple, brutal, effective. They define success. And third, static analysis. Linters, style checkers, vulnerability scanners. These catch things before you even run the code. Style issues, potential bugs, security smells. The real insight here, when you consistently feed agents these 3 types of signals, their output quality goes up dramatically, exponentially. A really common and effective starter stack for feedback is just compiler plus unit tests. Get that loop tight. Then maybe layer in static analysis, integration tests later.
Okay, but if we're using agents effectively, we might move beyond just one agent, right? Like a pair programming session. What about orchestrating multiple agents? Maybe one codes, one tests, one critiques. How does that scale?
Yeah, that's exactly where you start looking at multi-agent frameworks. Tools like OpenHands, LangGraph, AutoGen. These let you actually compose different agent roles. You can define a coder agent, a tester agent, maybe a security reviewer agent, and then wire the feedback loops between them programmatically. So, for instance, you could enforce a rule. The coder agent's output must pass the tester agent's checks and get a thumbs up from the critic agent before it even gets considered for a commit. This lets you bake your guardrails right into the architecture of your system, not just relying on hoping your prompt is good enough.
Which brings up that risk we mentioned earlier, agent drift. It sounds like a real thing. If the agent starts over refactoring or quietly expands the scope of a change or just forgets to delete test code, what's the actual cost? Does the fix outweigh the speed gain?
It absolutely can, which is why mitigation has to be architectural, not just wishful thinking or better prompting. The guide confirms drift is a persistent issue. You don't fix it by just telling the agent, be careful. You fix it by boxing it in. Strict adherence to those pre-approved plans, like in PDM, policy rules enforced by the orchestration framework, and yes, mandatory human reviews and sensible checkpoints. For security in particular, you need what the guide calls an integrated reliability loop. Tests, scanners, human sign-off, all part of the same CI/CD pipeline the agents are using. Security is just another vibe check, really, but with higher stakes and more sensors.
Okay, let's bring this home for the listener. We have the models, the tools, the feedback loops. What's the concrete, stripped-down plan? The realistic playbook to actually make vibe coding work for a team, say, starting this quarter.
Okay, 5 steps. Minimal viable vibe coding, let's call it. Maximum impact for the effort. 1. Pick one lane. Seriously, don't try to boil the ocean. Choose ICCM if you want sustainable speed with humans in the loop. Or, if correctness is absolutely king in your domain, commit to TDM from the start. 2. Seed the context. This is probably the highest ROI activity you can do. Implement CEM principles, index your repo, your docs, your API specs, an agent that knows where it is and what the rules are. It doesn't flail around. 3. Automate feedback. Non-negotiable. Wire compiler output and unit test it to every single loop. Make that feedback instant. Make it objective. 4. Control the terminal. Use a tool like Aider or Claude Code for those run, fix, repeat cycles. Discipline is key here. Commit small. Review often. Use those rollback or checkpoint features. Don't be afraid to undo. And 5. Decide when to trust, when to verify. Have a clear team policy. If code touches money, PII, safety systems. Verification via tests, TDM is mandatory. No exceptions. If it's a quick internal script or a throwaway prototype, maybe UAM is fine. Just accept the debt.
Perfect. And if we're starting fresh, brand new repository today, what's the essential starter stack to get the speed-safety balance right from day one?
Okay, bare essentials. For your editor, grab Cursor for that deep code base understanding, or maybe Windsurf if you really want that all-in-one plan, execute, review view. For your terminal discipline, pick Aider if you value clean Git history and easy rollbacks, or Claude Code if you anticipate complex changes where check plank wine will save your bacon. Feedback loop, minimal but mandatory. Compiler and unit tests, always, every single time the agent does something. And finally, context. You absolutely need a searchable index of your key architectural docs and decisions hooked into the agent's retrieval. That setup gets you moving fast, but with safety built in from the start. You know, if we zoom out for a second, vibe coding really changes the whole conversation. It's not if AI will help build software anymore, that ship has sailed. The question now is, how are you, the developer, going to guide these agents to meet your specific needs for quality, for speed, for risk tolerance? It's a spectrum of workflows, like we talked about, anchored by context and feedback.
So the bottom line seems to be, choosing your vibe coding stack isn't some philosophical debate. It's an engineering decision. It depends on your project, your team, your risk appetite. The really actionable takeaway sounds simple. Get a tight feedback loop running with tests, index your docs, use tools that respect your context and your Git history. Start there. Get that loop solid, then make the feedback richer. And here's something to chew on. Now that we have these formalized models, UAM through TDM, and we're seeing agents capable of more complex reasoning, how can you apply the idea of self-refinement, where the agent critiques its own plan, debates alternatives against the context before acting? How can you use that concept to boost your own critical thinking when you're facing a gnarly architectural problem? That structured internal debate, maybe that's a model for us humans too.